Hello guys, now let us discuss question 26. The question is, a radioactive nucleus A with half-life T decays into a nucleus B. At T is equal to 0, there is no nucleus B. At some time T, the ratio of number of B to the A is 0.3. Then the T is given by, the options are: first, T is equal to T by 2 log 2 by log 1 by 3. Second, T is equal to T log 1 by 3 by log 2. Third is T is equal to T log 1 by 3. Fourth is T is equal to T log divide by log 1.3. So the correct option is 2, because let us first make a diagram. It's A at T is equal to 0 for our easiness. It goes from let n atom decays, n atom decays into B in T. So it would be after that, after T time, it's A comma B 2. So it's n atom of B, and it's n naught, that is initial, minus n atom of A. So now we have NB by Na, that is 0.3. It's given in the question. Okay, so now n naught, that is initial, would be equal to 100 plus 30, that is 130 atoms. 130 atoms in total. Now by using the formula, n naught is equal n is equal to by using the formula, n is equal to n naught E to the power minus lambda T. Okay, by putting this value, we can say E lambda T would be equal to 1.3, and so now lambda T would be equal to log of 1.3 if we remove E. And so similarly, like that, if T is half time, then lambda is equal to log E2 by T. Then lambda is equal to log E2 by T, which implies it would be like, if we do like that, it would be T is equal to, as it implies, log 1.3 is equal to log E2 by T into T. So it would be T is equal to T into log 1.3 by log 2. That